A function is considered even if you put a negative x into the function for every x, the function doesn't change at all. It is considered odd if you input a negative x into the function and every single term of the function becomes the opposite of what it originally was. So it's easiest to understand that concept by seeing examples of it. So let's start with number 1 here. So if I put a negative x into this function, that means everywhere I see an x, I'm just going to write negative x. Now when you're testing for even and odd, you have to be very careful with exponents. Make sure you put your negative x in parentheses so that you know that you need to square the negative and the x. So when I square a negative, it becomes positive, so this is just going to be x squared plus 1. Now you can see that when I put in negative x, I got the exact same thing that I would have gotten had I just put in x. So that makes this an even function. Now with this one, I'm going to try putting in a negative x and see what happens. So that becomes just positive x squared. This becomes positive 2x, and that becomes plus 3. So you can see it's not the same thing, so it's definitely not an even function, but every single term is not the opposite of what it would be if we had just inputted an x in here. So if this had been negative, this had been positive, and this had been negative, then this would have been odd. So this one is actually neither odd or even. Let's try putting a negative x into this one. So if we put negative x in, I'm going to get negative x cubed over x, negative x squared minus 1. So this will give me, I'm going to bring this negative out. So because a negative cubed is going to be a negative, I'm going to put it right here because it makes it a little more obvious what the answer is when I do it that way. Over, and then this becomes just x squared minus 1. So the reason I brought it out was so we can kind of see that, notice this negative being out here is the exact opposite of what we started with, because if it was the positive one, now it's the negative one. So this is an odd function. You can also tell if a function is even or odd based on its graph. So a function is even if it is symmetric with respect to the y-axis, and it is odd if it is symmetric with respect to the origin. It's a little easier to tell even functions. That symmetry is a little easier to see. So for example here you can see that this is perfectly symmetric along this axis. This side is a mirror of this side, so this would be an even function. The odd one is a little harder to see because it needs to reflect kind of twice. It needs to reflect about the x-axis and about the y-axis. So if you see here, we have the point, if we go over 1, up 1, so right 1, up 1. If we go left 1, down 1, so the exact opposite on the other side, we have a point. So if I go right some value, up some value, I need to go left some value, down some value over here to get it. So this is symmetric about the origin. So essentially when you're symmetric with respect to the origin, you kind of flip it across the y-axis, or excuse me, I just did the x-axis. You flip it across the x-axis and the y-axis. So this one is odd. Now this one is also odd because you can see, like I was saying over here, if you go over 4 and then down 4, so right 4, down 4, you get this. You also will hit the line if you go left 4, up 4. So if you're looking at reflecting it about both axes, and it doesn't matter which order you do it in. So if we had this line here, and then we reflect it across the x-axis, we would end up right here. And then when we reflect it across the y-axis, we would end up right here. So this one is odd. The term even function comes from the fact that the standard quadratic function, so x squared and then x to the fourth, x to the sixth, x to the eighth, all of the standard functions with even exponents, they are symmetric about the y-axis. So you can see here, even exponent, symmetric about the y-axis, even function. The term odd function comes from the fact that those with the odd exponents, so x to the third, or just x to the first, x to the first, x to the third, x to the fifth, so forth, they are going to be symmetric about the origin, and they are odd functions with their odd exponents.